right, so this is our, let me see whether you can see. Okay, you can see already, first slide. All right, then, but hang on, where is my, okay, chat. All right. Now I'm going to go through very fast, so some of this I'll leave you to read on your own. Now, in set 3, you all will have to choose subjects in set 3. All right. So some of you will choose physics, some of you will choose biology. All right. So you either take physics or biology. Then all of you will take chemistry. Okay, so I'm just teaching you how to remember. This physics, right, will remind you of physical methods. All right, so there's such thing called physical methods, or sometimes we say physical means, either methods or means. Okay, never mind, I make it correct. Either you use methods or means. Then chemistry will remind you of the word chemical methods or chemical means. All right, now what is the meaning of chemical methods? Anyone knows? There must be what? New what? No one knows? New substance is formed. Something new must be formed. All right. So when you make something new, it's a chemical process or chemical method. All right. So just take note of this word. As long as you see the word, chemical, all right, chemical methods, then it means new substance is formed. If you see the word physical method or physical process or physical change, doesn't matter what word they use, they can use physical method, physical means, or physical change, or physical process. All right, as long as it's physical, that means nothing new is formed. So for example, ice melts to water. Ice is H2O. Water is also H2O. Nothing new is formed. Oops. Oh no. Okay. All right. For chemistry, chemical methods, right? Or chemical process or chemical change or chemical so means is all means new substance is formed, right? Then mixtures can be separated using physical methods. Why I use physical is because no new substance is formed. Right? So the word physical is because no new substance formed. Okay, so the separation techniques I'm going to learn today are all physical methods. All right, so mixtures are separated using physical methods. Right, so in your syllabus for set 1 and set 2 syllabus document, you need to learn all these methods, separation techniques, which I've showed the videos to you. All right, but do take note that distillation actually is separated into 2 types. Can you tell me, have you learned these 2 words, simple and fractional, in school? Can you type yes or no? Or does your teacher just teach you the word distillation? Does your teacher teach you simple distillation and fractional distillation? If yes, you type yes. No, you type no. Okay, forgot. Okay, so very important that you need to have these 2 words, simple and fractional. All right, can y'all tell me simple distillation is for what kind of mixture? So a mixture of, can you type in the chat what type of mixture? Solid plus solid, solid plus liquid, liquid plus liquid, what kind of mixture? Vidu, that's not right. Simple distillation. I give you a clue. You see simple start with S, right? So can you tell yourself it's S. S means solid, mixture of solid and liquid. So it's S plus L. All right, so for example, seawater. Okay, so this example would be seawater. Seawater is salt dissolved in water, right? Then fractional distillation is for mixture of, can you type into the chat? It's a mixture of what? For fractional distillation would be liquid plus liquid. It could be more than 2 liquids. All right, and these 2 liquids, they mix very well, mixable liquid. All right, means they mix very well, just like alcohol and water, they mix together into one layer. Okay, mix well. They dissolve in each other. All right, so this part is very, very important. Please remember them. So let me teach you how to remember. So if maybe I'll use yellow. So this is S, therefore S. All right. So this part might help you remember there's a solid dissolved in liquid. Then here is a liquid. Here liquid and liquid. Okay. So everybody clear? Simple distillation start with S. So it's a separate a mixture of solid and liquid. The solid must dissolve in the liquid. For example, salt dissolve in water. So if you want to separate salt and water solution, salt solution, you want to get pure drinking water from seawater, use simple distillation. Fractional distillation is like alcohol, it's a liquid, water is a liquid, alcohol and water, liquid and liquid mixed together, you use fractional distillation. All right, next, you need to know some examples of application, how you apply all these techniques in everyday life and in the industries, that means factories. Then you need to know Singapore's water treatment. Now, Singapore's water treatment, right, we are using a lot of reverse osmosis. Either we do reverse osmosis on seawater, all right, or we do reverse osmosis of treated used water. Treated used water means actually it's a dirty water, it's wastewater, all right, or your urine water or the water used by factories. Then you recycle the used water and make it drinkable. So for example, your new water. So this is how they make new water. They do reverse osmosis. Now reverse osmosis means they have a membrane. They force the water through the membrane. So it uses a lot of energy. All right, so reverse osmosis, let me write for you here, uses a lot of energy because you need to force the water molecules through the membrane. All right, let me write here, uses a lot of energy to force the water molecules through the membrane. Right, this membrane is a semi-permeable membrane. Why semi-permeable? Bacterial virus cannot pass through the membrane. Only water can pass through the membrane. All right, bacteria, fungi, sorry, not bacteria, but bacteria, viruses, they cannot pass through the membrane. All right, any questions so far? Okay, this one is an overall big picture of all the separation techniques. So I showed you all the videos. So you can click on this video. It will open up the link. All right, so please remember what method to use. So it's very simple. If you have something that's magnetic, which is iron and steel, they are attracted to magnet. So if you have two solid S plus L, one of the S is attracted to magnet, the other S is not attracted to magnet, then use magnetic attraction. Right? Then if you have L plus L and the two liquids cannot mix well, like oil and water, use separating funnel. So this is a separating funnel. So it's using density. The one with the lower density would be on top. All right. So that's using density. Vapor chromatography, the spot that is higher one means, can you tell me this spot now? It means this substance, is it the most soluble or least soluble? Can you type into the chat? This one. Is it most soluble or least soluble? If it's found on top. Type into the chat, please. This substance is most soluble in the solvent or least soluble in the solvent. Okay, good job. We do the rest. Most soluble or least soluble in the solvent. The rest, can I have a response, please? Because you told me you learned it already. You cannot remember, is it? All right. Quickly, please. Right. So the higher spot, right? So it is higher. So it means that it is the most soluble in the solvent. Okay. And then here you have the oil on top and the water below. Okay. Then I have told you fractional distillation is L plus L. Here is S plus L, right? Now here is also S plus L. This also S plus L. However, this S is insoluble. All these are soluble. Maybe I use a different color. All right, this is soluble solid, soluble solid. Okay. So if you have a soluble solid, solid can dissolve in liquid, and you just want to get the solid, you are not interested in a liquid, so you evaporate all the liquid away. That's evaporation to dryness. Then if you want both the solid and liquid, like seawater, you want the salt, you want the water, then you use simple distillation. If you have two liquids like alcohol and water, ethanol is one type of alcohol, use fractional distillation. Filtration is solid, cannot dissolve in liquid. Then learn the word residue and filtrate. So residue is left on the filter paper. So this is sand. It's known as the residue. Whatever resting on the filter paper is called residue. This will be your water. All right, which is called filtrate. Whatever that pass through the filter funnel is called filtrate. So you learn this word, important, residue. Learn the word filtrate. Okay, any questions so far? Right, then we move on. This one is a bigger picture of the two types of distillation. So I have told you already is water goes in here and water come out here. All right, so there are two layers. So the hot vapor will pass through here. The hot gas will pass through here and condense into liquid. So there's two layers. So this is the one where the hot gas passes through, right? So make sure the bulb of the thermometer is next to the side arm. The bulb of the thermometer cannot be lower, cannot be higher, so that you can measure boiling point more accurately. So inside, let me draw some boiling chips. So you can have some boiling chips. Okay, maybe I instead of doing this, I just draw this way and then here. Okay, so you can have some boiling chips. To smoothen the boiling process, right? Then if I ask you, how come, why is it that the water must go in from the bottom of this condenser? This is how you explain. Water goes in from the bottom of the condenser so that the whole entire condenser can be filled completely with water. And also, I want to increase the ESA. Do you remember ESA? Very important three word, but no short form. You need to spell it out. Exposed surface area. You want a bigger exposed surface area for faster condensation of the water vapor. All right, so you want the water vapor. It could be water vapor or it could be other things. It could be other gases. All right. So maybe not so much the vapor. As long I want the gas to condense quickly into liquid very fast. So I want to increase the ESA. All right. So that is why water must go in from the bottom. All right. Okay, I think this big photograph will show you much more clearly. This one is the tap. I open the tap, so water will run through this rubber tubing and goes in from the bottom of the condenser. So water will go here, then follow the rubber tubing, and then you waste water here. You throw this water into the sink. Right, so this water is thrown away. Okay, so this one is the distillation flask, or you can call it round bottom flask. So if you have a mixture of water and ink, dirty water, and then I can't be drinking this, right? But I can make pure drinking water and drink. I can drink this. Inside here, there's pure drinking water. So all you need to do is you use simple distillation. The ink is like a solid, you'll be left behind. All right, ink is a solid. Only the pure water will boil and then condense, and then it will condense into liquid here. Okay. Okay, fractionating column. Please learn the word. Let me label for you. This whole thing is the fraction. You spell, oh no. You spell fraction first, then nating, right, column. Okay. Right, so water in here. Then here is water out. Okay. All right, can you answer this question? How many substance does this black ink have? I'm using chromatography. So I put the